Assalamualaikum warahmatullahi wabarakatuh. On this video, I want to do a presentation about I want to review an article in English. So let's start it. The title of the article is "A Space and Time Efficient Technique for Big Data" by SecurityAnalytics, Suleiman Al-Suhibani from Computer Science Department, Qasim University, Buridah, Saudi Arabia. And the abstract. The increase of mobile application and social media are daily generating huge volumes of data. The variety of this data shapes an evolving term known as big data. Efficiently handling the big data seems a challenge to meet the rate of data growth. This challenge has played a significant role not only for indexing, but also for correlating events across space and time of big data security analytics. Therefore, this paper introduced a Bloom filter, or BF, which is a space and time efficient probabilistic technique. The BF and its variants are summarized in terms of their contribution to the network security domain. Besides, these variants are evaluated against the characteristics of big data security analytics. By conducting an experiment with a huge volume of data, the introduced technique along with an unsupervised learning engine is tested. The results showed that the BF can be used to overcome the efficiency lacking in the space and time of both indexing and analyzing big data. And the keywords. The keywords are Bloom filters, big data, security analytics, network processing. And we go to introduction. The increase of mobile application and social media are daily generating huge volumes of data and a very fast rate. This leads to develop technique for collecting structured and unstructured digital information, known as big data. There are numerous applications of big data, such as in social network, e-science, and healthcare. A very recent comprehensive survey has been conducted on indexing technology for big data. This survey stated that efficiently handling the big data seems a challenge to meet the rate of data growth. This challenge has played a critical role not only for indexing, but also for big data security analytics due to an exponential increase in the type of frequency of cyber attack. And number 2, Bloom filter and its type. Point A, Bloom filters. An overview. A Bloom filter is a simple space efficient randomized data structure to mainly support membership queries. In spite of the fact that BF can store a set of elements in a space-efficient memory, a small rate of false positive 1 may occur in membership queries. On the other hand, the space-saving and locating time features of BF constantly balance the downside when the probabilities of false positive take place. Point B, types of BF. There was 8 types of BF. The first one is standard BF. Second, Bloomer filter, and next compressed BF, and then counting BF. Number 5, dynamic BF, and then generalized BF, hierarchical BF, and space code BF. And this table number 1, summary of BFs and their involvement to the network security domain. And number 3, big data definition, characteristic, and indexing technique. Generally speaking, big data concept can be defined as collecting data that is integrated from different sources. This integration, therefore, produces different datasets that hold more variables of interest, accordingly reducing the size and time of analytical effort in analyzing the dataset seems a challenge. Thus, characteristics and indexing techniques of big data are discussed in this section. Point A. Big data characteristic. Number 1. Volume. It represents large dataset in areas such as scientific, government, and online social network. It also refers to terabyte, petabyte, or exabyte of stored information. Number 2, variety. Data is totally generated from different sources like structured, semi-structured, and unstructured data. And then velocity. It deals with the speed of receiving and transmitting data from various devices. Number 4, veracity. It represents data that is in fact sufficiently accurate, not spoofed or not corrupted. Number B, big data indexing techniques. Based on the aforementioned characteristic, existing indexing solutions may face a challenge in which their solution become inefficient. A very recent survey in an indexing technique for big data has assessed and classified index technique into 3 categories: non-artificial intelligence, such as hash-based indexing technique; artificial intelligence, such as fuzzy rule-based indexing techniques; and collaborative artificial intelligence, such as collaborative unsupervised learning-based indexing techniques. This survey hence concludes that CEI-based indexing techniques are effective for big data indexing and retrieval. And number 4, big data security analysis. The extraction of value of a crucial point in the domain of big data security analytics, or BDSA, specifically when this extraction is in threat monitoring and incident investigation, by focusing on discovering both known and unknown cyber attack patterns. Then it can be a concern for both financial and defense institutions. Unfortunately, traditional security solutions are not applicable for encompassing the real-time big data network stream by using traditional techniques. The efficiency lacking in the space and time can be the most likely reason behind why these traditional techniques were not applicable. And point 5, the experiment. And point A, implementation of CoBF. The CoBF is implemented using Java programming language. In order to count the occurrence of spam email message that is coincidental It occurs when a single cell is used by two or more email message and could increase many counters rapidly. And point B, volume of traffic email. The total number of email was 4 million emails. For this, multiple folders were used, with each folder containing 100,000 emails. Point C, implementation of unsupervised learning engine. A novel supervised learning engine is developed in our experiment by integrating an open digest-based hashing technique, which has been proposed in with CoBF. The main reason behind choosing this technique is as follows. First of all, it has to protect the message privacy. Consequently, encoding the message should be robust against planet attack. Number 6. Results. Point 1. Testing the recall rate. The recall rate refers to the ratio of found and inserted spam emails message. For this, 100 unique spam email messages are used and each spam message was respectively inserted. Then the total number of each pseudo spam became a specific number. 10, 20, 30 till 100. In this experiment, accordingly, when all the spam emails were inserted less than 50 times, 98% of the spam emails were found, while 99% of the message inserted more than 50 times were found. Point 2. Testing the false positive based on the recall result. When each spam email had been inserted 100 times, 99% of the inserted spam messages were found. Consequently, the false positive rate for each insertion is very low. Number 3. Testing the consumption of memory. The CoBF consumes only M size of cell bit to store an email message and their occurrence counts. Therefore, if there are 4 million email messages and M equals 4 million with 6 hash function, then it consumes about 28 megabytes. Number 4. Testing the consumption of time. The time needed to check for 4 million emails by. And number 7. Discussion. Initially, testing the recall rate appears to be a necessity for detecting spam emails by counting the similar emails. Because such a process needs a huge volume of email message, therefore the percentage of the recall reflects the accuracy. This implies the likelihood of using the CoBF for BigData indexing and retrieval. In addition, the email message and its occurrence count will be placed together in digital format, which could contribute clearly to a reduction in terms of memory consumption. Although the type can effectively detect the spam email message by counting the similar emails. Some improvement could be suggested in order to increase the performance in terms of server attribute for big data. That is, as handling the big data seems a challenge to meet the rate of data growth. A DBF type might be used to address this growth due to its dynamically feature for the size. And point 8. Conclusion and future work. This paper introduced a memory and time efficient probabilistic approach for effectively handling the big data to meet the rate of data growth. Moreover, the Bloom filter technique or BF and its variants are summarized in respect of their contribution to the network security domain. Besides, the big data security analytics are evaluated against the BF and its variants by conducting an experiment with a huge volume of data. The introduced technique along with an algorithm for extracting the data is tested. The results showed that the BF can be used to overcome the efficiency lacking in the space and time of both indexing and analyzing big data. One of our future works is to implement the DBF and evaluate its performance against the CoBF. With regard to the big data indexing and retrieval. So this is the part of the references, and this is a lot of reference here. You can see it and you just skip. And thank you. So that's it. And I hope you enjoy this video, and Assalamualaikum warahmatullahi wabarakatuh.